So at some point you have to recognize that whenever it's the same on the left, same on the right, that it's infinite solutions. Is that clear?
Yeah.
Okay. So you got to know that. So we are done. That is the teacher wants to see something like that as your final answer.
Got it.
Okay.
And then I believe the other one that I wanted to go over was number 9.
Yes. Yes. I'm getting to that. It's never as easy. Where is it? There it is. Okay. There it is. Number 9. Okay. So again, you could look for these shortcuts. Both equations can be divided by a number that goes on. Like the first one can be divided by 3. The second one can be divided by 5. And when you see something that goes into all of them, you should reduce them. So it becomes x minus 2y equals minus 9. That's the first equation. The second equation becomes minus x plus 2y equals 2. Now, if you really wanted to, you can do the whole like multiply by 5, multiply by 3, or multiply by 10, multiply by 6. That's okay. But you should look to save time that you can divide the equations.
Got it.
All right. So now the first thing of elimination that you learn when you're learning elimination is you always start by just adding the equations together. Tell me what happens when you add these equations together. What do you see?
Yeah, those equations together both cancels out.
Both
Both the x
variables
and the
cancel
y.
out.
Yeah, both variables.
Is this true though?
No, it'd be no solution.
Yeah,
Or
no solution. Yeah, not a true statement. And so you got to be constantly on the lookout for that, the exceptions.
yeah. So there can be one solution, infinite linear solutions, and then no solution.
Yes, those are the only possibilities for a 2 by 2 system, which is what you have here. You guys are going to do 3 by 3 systems as well, 3 equations, 3 unknowns. Now there'll be another
Um,
possibility. Now, we maybe should do some systems where you have to solve them by actual elimination, like what you were doing here, but none of the ones you sent over are like that. And in
yeah,
fact, 5, 6, and 7 are all substitution problems. Um, they're not the pure elimination type. Pure elimination is where you have to multiply both equations by a number, or divide, I guess, in this case. So I've got some, or I can find some, or if you got some more questions you want us to
um,
do.
so now on today's homework, I do have some questions. So I did get started on earlier. Some of the ones I have questions on here, let me take a screenshot of them. Take a screenshot of them. All right, there are the instructions, and then the question is below it. It's their kind of part.
Find the points of intersection of any of the graphs of the system. If any of the graphs in the system, check on a graphing calculator. Okay. What I'm not clear on, Karthik, you're gonna have to help me out here, is are you solving these with a graphing calculator or you're just
Checking them.
checking them with a graphing calculator?
Yeah.
You're just checking them?
Yeah.
Okay. All right. So nonlinear systems, which is what these are, they are generally solved by substitution. Most of the time it's by substitution. You can still use elimination to some degree, but mostly it's substitution. The first equation we need to expand this. There's not really a good way to do it without that. So you got to write -1/2 x plus 4 times x plus 4 plus 7. So you have to be really comfortable at foiling this. X squared plus 8x plus 16, then -1/2 of all of that. All right, so this is -1/2 x squared minus 4x minus 8 plus 7 becomes -1/2 x squared minus 4x minus 1. And so that's all the top equation. The bottom equation, we are going to bring down and set it equal. So it's 1/2 x squared plus 2x plus 7. Any questions on what we've done so far? The FOIL, combining like terms.
No.
All right, now this one, like we have to decide which way to move things. I'm going to move everything to the right because we want to keep x squared positive. So I'm going to add 1/2 x squared. I'm going to add 4x, and I'm going to add 1. So this is x squared plus 6x plus 8. And this is where you are going to rely on all the tools that you learned from previous chapter. You're going to um, for example, here you could factor this. Two numbers that multiply to 8 but add to 6.
At 8, 4, and 2.
So x plus 4, x plus 2.
That mean x equals -4 and x equals -2.
So x is -4 and or x is -2. Now these are only part of the answer. You
Yeah, now you
have
gotta
to,
plug it in.
now it does not matter which one you use. So I would use the first one because you only substitute in one place. That's my
Yeah.
reasoning. You can use the second one. What it's just up to you. You decide. You're the math student, you decide. So for this first one, y ends up being 0. For the second one, it's a little bit more difficult. Oh, just be clear on the first one, -4 plus 4 is 0, 0 squared is 0, times 1/2 0, -0. Sorry, 7, y equals 7, not 0. Second one's a little bit more difficult. -2 plus 4. So that's 2 squared, that's 4 times -1/2 is -2 plus 7 is 5. All right, so uh, this shouldn't surprise you that there's two answers.
Yeah,
If
because
you look at a
squared.
parabola, it's
Yeah, it
possible they
touches
could hit
2
twice.
points.
Okay. It's not guaranteed though. Like if they go in the same direction, they might only hit once. It's also possible that they don't intersect at all. It's also possible that they just touch in one place, but it's typically 2, 1, or 0 solutions. So you want to be on the lookout for all of those as possibilities.
We the next one that was kind of this one is number 3. Let me start which. Here's the next one that I was kind of confused on.
So for this one, we're going to start by talking about what it actually is the graph of, which you may not know, but when both are squared, do you remember what that is most of the time?
Uh, circle.
Circle, yeah. There are other possibilities, but this one is a circle. The second one is a quadratic. So here are some possibilities. Here's a circle, and here's a quadratic. How many times could they intersect?
4.
Four. Here's another possibility. They could hit 3 times. They could hit twice. They could hit once, or they
Yeah,
could miss altogether, right?
yeah,
So all of these are possibilities, meaning like, don't be surprised if you get, now what are you going to probably get? You're probably going to get either no solution, 2 solution, or 4 solutions. You're probably not going to get one of these weird ones. These are hard to do, but they're possible.
yeah.
Okay. So to solve this, I'm gonna grab this again. You, for example, could multiply everything by -2 to eliminate the x squared. So you could use elimination here. You could solve this first equation for x squared and substitute it in here. Do either of those sound familiar to you from class?
Um, I think in class what we do is you set the second one equal to y, then plug it in.
So solve for x squared then, for example.
Yeah.
Okay. So from the first equation, x squared is equal to 64 minus y squared. That's going to go in right there into that equation for all of that for x squared for the whole thing. So this becomes 2 times 64 minus y squared plus y minus 8 equals 0. And that's 128 minus 2y squared plus y minus 8 equals 0. Is that okay?
Yeah.
All right. So like this is really, I don't like at all the way this is written because it's got just problems like the negative y squared, it's got like terms. So if we rewrite it, -2y squared plus y plus 120 equals 0. Um, what I would like to do is change the sign of all these terms because I really want that leading one positive. That's just a comfort thing for me.
So you're basically multiplying the entire thing by -1.
Say that again.
So you're basically multiplying the entire thing by -1 to make
Exactly.
the
Yes.
coefficient.
Yes. Yes. Good. Good. Or you're moving it to the other side. Yeah, that's correct. Okay. Now this is the hard type of factoring because the leading one is not a 1, it's a 2.
So you complete the square.
I would not consider it. I would multiply the 2 times the negative, 2 times negative
Oh,
120, which
AC,
is
then
-240. And then this is where it is kind of annoying. You got to find two numbers that multiply to -240, but add to -1, which means they're 1 apart, which means the two numbers are like right next to each other. And I don't even know if this works. So let me go and check. This would probably be a calculator problem. probably. Minus X minus 120. See if this actually does work. Yeah, it does. Okay. Wow. So what are the numbers? Okay. So it's 15 and 16 are the numbers, and it's negative 16 because
Because it
you have
has to
to
be
get
negative.
-1. Yeah. So now you ask yourself, which pair's better with 2y squared? And the answer is 2y squared minus 16y plus 15y minus 120. And then you factor out the GCF from this. So 2y, you factor out a 2y, and you get y minus 8. And you immediately put that over here to the right, and you have to figure out what goes in the middle such that when you multiply in, you get back to this. And then you'd factor again. So y minus 8, 2y plus 15 equals 0. And then you get y equals 8, y equals minus 15 over 2.
Got it. And then now you plug it into the y's for where's the
Yeah,
equation.
it's like, which one to use? Well, uh, it's just not good. I guess I'd use maybe this one because it's kind of solved for, but yeah, it's not good. Um, because you're going to get multiple solutions here. So if x squared equals 64 minus y squared, when you put the 8 in, you get x squared equals 64 minus 8 squared, which is 0. So we know that x is
Yeah.
0. That's okay. But for the other one, you get x squared equals 64 minus 15 over 2 squared, which is 225 over 4.
Then you have to square root it as well because
Yeah, we're going to combine these first. So this is 2, yeah, 128, 256 over 4 minus 225 over 4, which is 20, 31. Does that look right? 31. But it's plus or minus. So x squared equals 31 over 4. It's plus or minus 31 over 4, which is plus or minus the square root of 31 over 2, like that. And so, right, like this is all good, but you have to present your answers. So your answers have to present it this way: 0, comma 8, that's your first one, comma, square root of 31 over 2, comma, minus 15 over 2. And then your last one here is negative square root 31 over 2, comma, minus 15 over 2. Is that good enough for you on this one, or do you have some other
Yeah, I think I
questions,
get
thoughts?
this. Yeah.
A lot of algebra, a lot of moving pieces.
All right, the next one I'd like to go over is one of my complicated ones. Page number 7.
Boy, yeah, so there's a lot here. The first one is a circle, the second one is a circle, and the third one is a line. Okay. And they have to like all work. So boy, we're in kind of a like, what do we do situation here with this. Are you allowed to graph these, or are these all by hand?
I think these are all by hand and you check it on the graphing calculator or the graph or Desmos.
Okay. Trying to think of how to even suggest to proceed here. Okay. The uh the first two equations, we just look at those. If you were to subtract, you were to take the first equation and subtract the second, the x squareds would cancel, the y squareds would cancel, the minus 4x's would cancel. Do you see that?
Yeah.
And that's really good. It's really good because basically everything clears out. I don't know how to tell you to know to look for that. I had to sort of like think about this one, look through it, oh yeah, there it is. Like it's not obvious. It's one of those things where once you've done a few hundred of these, you know all these techniques. But that is the strategy here. So you take the first two equations and you combine them the way we just described here. So if you don't like subtracting, like some students like they're really uncomfortable with that, you can multiply the second equation by -1. That's also a strategy here. So you get negative x squared minus y squared plus 4x plus 54 equals 0. And then you bring that other equation down, x squared plus y squared minus 4x minus 4y minus 26 equals 0. And then you can add them together. Like some students are much more comfortable adding. It's up to you. If you're okay subtracting, just subtract. If you want to multiply by -1, then do that. So these cancel, these cancel, these cancel, and you're left with minus 4y plus 28 equals 0. And you can actually solve this for y. You can actually solve this for y. Y equals -7. Sorry, +7. That's surprising. It's like, whoa, like this actually worked out. It's like, yeah, it worked out pretty nicely. You can then go back to the previous equations to solve them for x. Okay, like you can use this last equation here to get the x value.
All right.
7 equals 3x minus 8. 15 equals 3x. X equals 5. Okay. Any other thoughts on this?
Um, not no.
Okay. Now we should graph these because I'm curious. I actually think there could be more solutions here. 'Cause if we took this y value and put it in here, 49 minus 5. We would get another x value out of this. And that would also give us another y value. But I think the thing is that this is the only one that works in all of them.
Uh, yeah, because it probably would be more solution.
I'm gonna graph. Okay. So this is actually kind of an SAT style question because when you look at the graph here, I've got the graph up. The solution to the system has to be all three. All three intersect, which is only right there. So
Got it.
now it happens to be that the circles intersect twice, which is kind
Yeah,
of cool, but they
and
have to all three intersect there,
because the line does intersect each of the other circles,
right?
like down there, but it doesn't
Yeah,
intersect all three at once. Got
yeah.
it. Yeah, that makes sense. So if it's a system for the system that has to intersect all three or all two, I guess, of it. But if it's three equations that intersect all of them, got it.
You're always looking for some sort of a shortcut, like I was talking about here, where you subtract and combine and stuff like that.
Uh, oh my God. Right, the next developer is in the chat now.
Okay, so this one here, Copy. All right, so again, kind of important to know what the shapes are. So if I were you, I should have mentioned this earlier. You really should graph these first so that you know like what you're looking for. So you're not surprised by the number of solutions. The first one is some sort of a quadratic. It looks like it opens up. The second one is some sort of an ellipse, which you haven't, something like that. So there could be two.
So they can be four total solutions.
Could be four, could be two. So to solve this one, I think the best thing to do is to solve this first one for x squared.
I got x squared equals 4 plus y.
So y plus four, so that's going to go in here. So here we're going to solve 3y squared minus 3y minus 6 equals 0. I would recommend solving this by factoring out of 3. Okay. And then you can go ahead and solve this by factoring, get your y values, and then we'll go back to the x squared equals y plus 4 to get the x values.
All right. I got y equals 1 and y equals -2.
Okay, very good. So the thing here is that for each of these, you're going to put them into this equation. So the first one produces x squared equals 1 plus 4. So x squared equals 5, and x equals plus or minus the square root of 5. So that's where you get these two solutions. You get the square root of 5 comma 1, square root of 5 comma -1. For the other one here, it's x squared equals -2 plus 4, which is x squared equals 2, x equals plus or minus the square root of 2. So that becomes square root of 2 comma -2. Oh, sorry. Yeah, square root of 2 -2. Negative square root of 2 comma -2. Like that.
Wait, wouldn't the second one be square root of 5 comma 1 and
Sorry.
yeah, and square root of negative or negative square root of 5 comma 1?
Yeah. Yes. Good catch. Yeah. And this is +1. Mistakes all over the place. Right. Any thoughts on that? Questions or anything like that?
Um, mm, no, I think I got that one now.
Yeah, cool.
Um, I'm just gonna go over. Number 5.
Okay, got another one here. All right. All right. So for me, when I see something like this where one of the variables has been solved, kind of almost solved for, like this one, I tend to think, okay, let's solve for x here. X is, 2 minus y squared, and that would go into the other equation. What I try to avoid, Karthick, I think is really important. Like if you solve the first one for y, that's great, but now you got to square it. It's not so good. I'd rather avoid that if we can. That's just a preference. That's a time savings thing. Does that
Uh,
make sense? Like you can solve for y and put it in here and square it, but it could get messy. Yes, no, maybe.
yeah, I plug it in for
Yep. 6 minus 3y squared is y equals 8. and move
Mhm.
everything right this time. You don't have to show all these steps, but just doing it for the. Right. And this one you solve using that factoring approach we did earlier. Um, so 3 times 2 is 6.
6, and then 6, so that's equals, so that'd be
Ooh, we got a problem here.
3 and 2.
Yeah, they don't have to -1 though.
Uh, oh,
So,
negative
uh,
2, negative 3 and 2.
no, that doesn't work because they gotta multiply to +6. I'm looking to see if I made a mistake. And I'm gonna quickly graph this because it's possible there's no solution. So let me just check. Yeah, this one actually has no solution. So, well, how you would figure that out is when you use quadratic formula on this, you would get no solution. You'd end up getting your discriminant, your b squared minus 4ac would be less than 0. So you'd end up having the square root of a negative in there. This is confirmed with the graph. Sorry, we're kind of rushing. We're running out of time. These don't intersect.
Got it. Yeah, then that would definitely be no solution because it doesn't cross the other equation at all. Yeah, that makes sense. How we were able to find the factors for the various style points that intersects. Right. Yeah. Yeah.
All right, so we are all done for today. We're out of time. So let me go ahead and stop the recording.